Hello everyone, my name is Muhammad Azjad Ahmed and I am from Institute of Aeronautical Engineering, branch Aeronautical Engineering from Section A, and my roll number is 20951A2142. Now this is physics my physics session, and my topic is acceptance angle and acceptance cone, numerical aperture. These are my in this session, these are my three topics, and by the name we can understand it's from fiber optics, which is of module 3 from our engineering physics. So we know that fiber optics means it is a glass or a plastic tube which is covered with an outer jacket. For its mechanical protection is known as optical fiber. And there are a wide range of optical fiber uses. They are it with the principle of total internal reflection. As we know that it works on the principle of total internal reflection, uh, it will transfer light in a type of energy for a longer distances in a zigzag motion. So at every reflection inside the optical fiber, there will be contact with light contact with axis of fiber. So with that only we are deriving acceptance angle, acceptance cone, and numerical aperture. Let us go through acceptance angle. So what is acceptance angle? So light should be launched in the fiber at its one end using focusing lens at a certain angle, such that the entire light must pass through core and no rays are refracted at the cladding and are lost. So as there is no loss of energy, it's a law of conservation of energy. Neither energy is losing nor it's creating. So there is no loss of energy. That is why in our current situation, in our current circumstances, the optical fiber is used widely. So what he's saying is that this is the axis of fiber, and this is the light propagating on this core refractive index. This is core, this is cladding. So what he's saying is that light is launched at the core ending in such a way that it should be not refracted into the medium of cladding. It should get reflected into that core in a zigzag motion. So as you can see that at every zigzag motion it gets contact with this optical fiber axis. So that angle at which the beam of light is propagated in such a way that it gets total internal reflection at the core and no rays are refracted to the cladding or lost, it's known as acceptance angle. So what is acceptance angle defined as? It is defined as the maximum angle of incidence at the end face of the optical fiber for which the ray can be propagated through the core material along the core cladding interface. So it is called as acceptance cone half angle. So what he is also trying to say is that to get the total internal reflection, we should choose the maximum angle at which so it is critical angle at which we should propagate the light so that it should form a total internal reflection inside the core. So as you can see, this light ray, it's get propagating inside without the loss of this cladding interface. So it will go along the length of the optical fiber and it gets exit from the other end. So as indicated, this is core, this is cladding, and this is acceptance angle. So acceptance cone is also it's easy when you understand acceptance, the process of acceptance angle. Acceptance cones is also easy because you can see here that it is striking the this axis at an high angle. So that's the critical angle. It is mean critical angle that it does not interfaces the axis. It gets refracted into the other medium and gets reflection, total internal reflection inside it. So let us, we know then what is acceptance angle. So acceptance angle is also defined as theta equals to sine inverse of numerical aperture. That is acceptance angle. It means it's a maximum angle of incidence. Now let us go through acceptance cone. So this is our acceptance cone. As you can see, this is the fiber axis. This is light path which is in zigzag motion as we have described. So this is core, this is cladding. This is interface of core and cladding, and this is the medium at which we should propagate a light so that it gets maximum angle of incidence and gets total internal reflection principle. So acceptance cone means the cone obtained by rotating a ray at the end face of an optical fiber around the fiber axis with the acceptance angle is known as acceptance cone. As we have mentioned before, the turning of the, rotating the ray at its end phase, then this is the ray, if we rotate it, it will become cone. So this is the acceptance cone at the acceptance angle. So light launched at the fiber end within the acceptance cone along will be accepted and propagated to the other end of the fiber by total internal reflection. So what is the use of this optical acceptance cone is that if we propagate a light and it's becoming a acceptance cone, right? So in that area of acceptance cone, anywhere if we propagate light, then that will be accepted by the optical fiber and gets total internal reflected and gets from the other end. So larger acceptance angle makes launching easier. So it is directly proportional. As the larger acceptance angle, larger will be the launching will be easier. So third one that we go through is a numerical aperture. Numerical aperture, by this I think we are very familiar with this word, numerical aperture. Aperture means related to the optics only. So numerical aperture is a measure of its light gathering capacity. So the maximum light gathering capacity by an optical fiber is known as numerical aperture. So see here, as you can see, we have stated first, its maximum acceptance angle. Sine of the maximum acceptance angle. Numerical aperture is a sine of the maximum optical acceptance angle. So as you can see the derivation, how it's becoming, what's the formula of numerical aperture, you will understand here. Numerical aperture is denoted by NA, and it's a numerical aperture is gathering of light capacity by an optical fiber. So it should have more, as we have seen in acceptance cone, that larger acceptance angle make launching easier. That means the larger acceptance angle means the more the angle will be, the larger the maximum. See here, the maximum the angle will be, the numerical acceptance, it is easier to launch. So numerical aperture means the larger the space, the cone of the space will be, the more gathering of light. So sine of alpha is equals to n12 minus n22. This is the first expression that we have got. Now we know that it is square actually, not 2. n1 square minus n2 square. We are familiar with a square minus b square formula, which is a plus b into a minus b. So n minus 1 into n plus 1. So as we know that, we are also familiar with, if we have studied, we have also familiar with the fractional differences, which is delta equals to n1 minus n2 divided by n1. So here n1 minus n2 is there. So it will, if the n1 goes here, then n1 minus n2 will become n1 lambda. If we put n1 lambda here into n1 plus m2, this will be the expression. Now it is used for the problems which if the fractional differences are given. So here, as we know, n1 is the refractive index of core and n2 is the refractive index of cladding. So there is when a light from a denser medium gets gets refracted or gets jumped into the another medium of core refractive index, either it may be air, water, and anything. So this is that's how we can find numerical aperture, acceptance angle, and acceptance cone. They are interfamiliar with each other, as you can see this. So acceptance angle formula, as I have said you, theta is equals to sine inverse of uh, numerical aperture. So it's a highest language. With this formula also we can get the formula of numerical aperture as it numerical aperture formula is n1 minus n2 by n1 we are getting from here. So numerical aperture is also defined as n1 delta n1 under root of 2 delta. So it's also have that formula also. So as for now, re-summarizing the concept, what is acceptance angle, what is acceptance cone, what is numerical aperture. So as we know that acceptance angle is the maximum angle which is of a light propagating the surface of the core to get total internal reflection under the acceptance cone. Area of acceptance cone is known as acceptance angle. As from acceptance angle you can get acceptance cone. That means when we rotate the axis of the process of acceptance angle, then it will become a this cone. Now that cone will help you understand the gathering where we have to propagate the light in a particular space to get total internal reflection, and numerical aperture is the gathering of light. Gathering of light is known as numerical aperture. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.